Support Moof University in the production of more video tutorials by making a financial contribution or by getting yourself one of these t-shirts. Details under the Support Moof section on moofuniversity.com. The link will be in the description below. Thank you and enjoy.
Alright, so we've talked about the idea of certainty versus uncertainty, and when we were talking about significant figures. Now I want to talk about precision, accuracy, and error and how that plays into the idea of certainty. So certainty can basically be divided into precision and accuracy. And what are these things what do they mean? Right? We hear these words sometimes, but what are they when we're talking about them in terms of science and measurements? Precision describes reproducibility of measurements, or how close measured values are to each other. Whereas accuracy describes how close a measured value is to the actual value, or the true value. So what does that mean? Okay. Well, let's think about this in terms of the classic way to describe this is an archery board or a dart board. I'm going to talk about it as if it's an archery board. Okay, so the target, of course, is the center. That's the bullseye, right? And we want to hit that with our arrows. So let's say we're shooting 5 arrows. Okay. Let's say we shoot 5 arrows, and this is where they hit, right here. 1, 2, 3, 4, 5. They all hit right there. In this case, we've got a case where we have lots of, let's call precision P, and let's call accuracy A. So here, this is very precise, but very low in accuracy, right? High precision, low accuracy. Because the actual target is that center, right? The bullseye, and we're really far away from it, right? But we're really precise because every single shot is, they're really, really close to each other. The reproducibility there of the measurements is really, really high, right? If you imagine that in a lab, measuring the same value over and over and over. So in this case, this is very precise, but inaccurate. Okay. Now, what about the opposite case? Could we have a case in which we have low precision and high accuracy? Kind of, but not really. I mean, this is as close as it gets to it. Let's say we want to be more accurate, right? Let's say we hit those 5 shots and they end up being here, 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 and here. Okay, so here this is more accurate because we're closer to the actual value, the actual target, right? The actual bullseye. But we're not as precise. Our values are a little bit further away from each other. Now notice it's still fairly precise because these values are kind of close to each other, but over here they were like one tiny bunch, whereas here they're spread out a little bit more, right? So this is less precise but more accurate. Okay. The ideal would of course be to have high precision and high accuracy, right? And in that case we'd have maybe all 5 hits dead center. 1, 2, 3, 4, 5. You can't even tell that I'm putting 5 little dots or 5 little stars there, right? That would be highly precise because all the values are there, all the shots are there, and highly accurate because they're all at the true place where we want them to be. Of course, we could have a case where we could have it, low precision and low accuracy, right, with shots all over the place and not even close to the bullseye, right? Let's just do a quick example of that. If we had like a shot here, a shot here, shot here, a shot here, and a shot here, that's not precise or accurate, right? In green there, because they're not all in the same place, and they're all far away from the actual goal or target. So that would be inaccurate and not precise. Now, aside from that, precision and accuracy are also defined in terms of the 2 types of errors that we're going to discuss here in this video. And those 2 are random error and systematic error. So what is random error? Random error is when measured values are both higher than actual values and lower than actual values. Okay, so this is both, right? When measured values are both higher and lower. than actual values. So you get measurements that are higher than what the true value is and lower than what the true value is. And this always occurs. This random error always occurs, and it depends on how skilled an individual is at taking measurements and the precision of the instruments that are used to take the measurements. So when we talk about precise measurements are defined as having low random error because they're precise when you can reproduce the same value over and over and over, right? But if you have a specific target value, right, the accurate value, and you have values that are measured above it and values that are measured below it, then you're not being precise, right? You're not getting them all basically in the same spot. Okay, so precise measurements have low random error, so they're defined in that way. When it comes to systematic error, that's when measured values are either all higher than the actual value or all lower than the actual value. So here, this is an either-or situation, unlike with random error. Right? Before, it was both higher and lower. Here with systematic error, either all the values that you measure are higher or all of them are lower. Right? And this can be due to something else. This is not. This can be due to faulty measuring equipment or devices that are used to take the measurements. Right? Or a particular individual that's taking these measurements is consistently repeating the same mistake when they're making that measurement. Right? So this can be accounted for and reduced slightly and hopefully eliminated, to be honest, by calibration of the equipment that's used or the devices that are used to make the measurements. And calibration basically means that you're taking this equipment or these devices and setting them to a known standard to make them, capable of taking as close to correct measurements as possible. And so when it comes to accurate measurements have low systematic error, and they usually have low random error as well. And the reason for this is that it's if you're accurate, you're probably also precise, right? Like if you take 5 measurements and they're all pretty much right on the money, right? Well, they're all around the same area, right? So that if they're accurate, they're probably also precise. So that's why I added this little pink part here, and usually have low random error as well. So I hope that video was helpful in kind of wrapping that up. Thank you for watching.
If you found that video helpful, be sure to hit it with a like, and don't forget to subscribe if you haven't already. Also, be sure to share the video with anyone who you think might find it helpful. Thanks, and happy studying.